assessment and mapping vulnerable wetlands in Massachusetts. We will be beginning with the New York City Tidal Marsh Assessment presented by Chris Haight of the New York City Parks and Recreation Department, followed by a brief Q&A for Chris. Again, if you find you'd like to ask a question during the presentation, please send it to me via the chat box under Kimberly Roth. Then we will see Mapping Vulnerable Wetlands presented by Nancy Lynn and Alice Smith of MassDEP. After this presentation, we will have another brief opportunity for Q&A for Nancy and Alice. And then we will follow all of this with a discussion of both presentations and how these innovative techniques can be applied to programs and what impacts they make in wetlands programs and ecosystem health. To introduce myself, my name is Kimberly Roth, and I'm your Wetlands webinar series moderator. I'm an environmental analyst with the New England Interstate Water Pollution Control Commission, or NEWIPIC, and I manage our wetlands program. We're starting off with Chris Haight. He works for the New York City Department of Parks and Recreation in the Natural Resources Group as a project manager for wetland and riparian resources. Chris manages 2 EPA-funded projects that assess the condition and vulnerability of natural and restored salt marshes in New York City. Chris has previously worked as a research assistant for the Marine Biological Laboratories TIDE project, a large-scale salt marsh fertilization experiment in the Plum Island estuary of Massachusetts. Chris has a BA from Connecticut College in Environmental Studies and an MA in Conservation Biology from Columbia University. You're on, Chris.
Great, thank you so much, and thanks for everybody who's listening in. Let me see if I can change the slide here. So I will be talking today about our EPA-funded salt marsh assessment study where we're evaluating the conditions and vulnerability of salt marshes in New York City. For some reason, I'm not able to change the slide here yet.
Give it a big swing and then try and look down, there you go.
Oh, okay. All right, here we go. So we're doing this project in collaboration with the Natural Areas Conservancy, who is a nonprofit partner of New York City Parks, as well as the Nature Conservancy in New York. New York City, like many coastal cities, has lost a lot of its historical wetlands in the past few years. This is a map showing in pink and purple the historical wetlands in New York City, and in green are the currently existing wetlands. New York has lost about 80% of its wetlands, and currently we have about 4,000 acres of remaining wetlands. In this study, we assessed 1,000 acres of wetlands in New York City, across the city, in 4 boroughs in the Bronx, Queens, Brooklyn, and Staten Island, and on the water bodies of Long Island Sound, Jamaica Bay, and the Arthur Kill and Raritan Bay. These are all on natural salt marshes, so no restored salt marshes, and it's all New York City property. So it doesn't include places like in Jamaica Bay, the Jamaica Bay Islands that are national parks property. So the goals of this project were to evaluate the current salt marsh condition and assess vulnerability primarily to sea level rise, and then also identify opportunities for protection and restoration and prioritize those opportunities. Now, we did this through a number of different methods. We created a conditions and vulnerability index, and the inputs and metrics that go into those indexes were largely taken from field metrics, such as our Mid-Atlantic Tidal Wetland Rapid Assessment Method, which was used to compare salt marshes in New York City regionally with marshes in Delaware. And we also did a more in-depth assessment at each site using the Salt Marsh Ecological Assessment developed with Natural Areas Conservancy, characterizing vegetation and soil properties across the site. And we also set up a longer-term monitoring plan at 6 sites where we have a site-specific intensive monitoring, which includes things like surface elevation tables and creek erosion pins that we monitor each year. And we also did a detailed marsh loss analysis comparing the 1974 wetland extent to the 2012 wetland extent and seeing how much changes occurred over that time period. And we used the sea level affecting marshes model, which is a sea level rise model that was applied to New York by Warren Pinnacle, funded by NYSERDA. So all of these, I'm not actually going to get into the details of our findings for all of these different things, but these are the metrics and components we pulled from these to go into our conditions and vulnerability indexes. To go more into the sea level rise model, which is important for our vulnerability index specifically, as I said, it was applied by Warren Pinnacle to New York, and it has 4 sea level rise scenarios that are just downscaled global climate models from New York State. And it has 4 time horizons, but what was most interesting and what we ended up using is their uncertainty layers or the likelihood layers that are essentially an average of the sea level rise scenarios and give you a trajectory or likelihood of change at a given location for a time horizon. But in using this model and these maps, you always have to be cautious as they do show beautiful information and maps, but you can't really take them literally. It's better to think of them as a trajectory as to where, you know, the sea level rise is headed. And we specifically use the time horizon of 2085 because it's a time when you see noticeable change, and it's also not so far into the future that it's still relevant to planning. And this is an example of the uncertainty layers where we pulled the likelihood of coastal marsh information out of, again, for the 2085 time horizon. You can see here in the green, it shows that the areas in green have a 75% or greater likelihood of being coastal marsh in the 2080s, and the areas in red have a 25% likelihood or less likelihood of being marsh in 2085. We pulled those 2 categories to determine our potential marsh migration by looking at the likelihood, 75% or greater likelihood of being coastal marsh outside of our marsh complex, as well as looking at potential marsh loss by looking at areas that have a 25% likelihood or less within the marsh complex. And these 2 metrics were used in our vulnerability index. So building the conditions index with the Nature Conservancy and the Natural Areas Conservancy, we used the Nature Conservancy's conservation action planning approach to identify the different metrics and build the index. And these are all, again, pulled from our field assessments, largely, as well as desktop analysis and landscape data. And, you know, these metrics include things that cover, you know, the marsh size, habitat, as well as indicators of interior marsh change and fragmentation. And so all of these metrics were scored using or standardized using a Z-score and then averaged to get a total score. And we use the Z-score because it's a good way and a common way of adjusting for variance and units, and it centers each value around 0, with 0 being the average and positive numbers being above the mean and negative numbers being below. And this allowed us to then rank all of our sites according to condition. And here this chart shows in red the lower condition sites and then scaling up to the higher condition sites in blue. The colors are just to visualize the ranking. And also something to note on this is that this is all relative to the sites in New York City. So this isn't an absolute condition assessment. It's just relative to across New York City. So these were the scores we got for condition. And then going into the vulnerability assessment, we, again, selected metrics, and here's where we included the potential marsh gain and marsh loss from the sea level rise model, and we also included the size of the marsh, the wetland trend, which is the amount of loss that the site has experienced since 1974 to 2012, and then also looking at edge density and percent high marsh as an indicator of elevation deficit. And now here's the ranking for our vulnerability index, and now it's flipped. So you have the red, or the higher vulnerability, are positive, or positive numbers above the mean, and then the lower vulnerability sites are actually negative z-scores below the mean. And so these are our rankings across New York City for those. And if you compare the conditions index to the vulnerability index with higher condition on top and lower vulnerability on the left, you can see with the points in green for Staten Island, blue for Long Island Sound, and red for Jamaica Bay, that a lot of the Staten Island points are in that higher condition, lower vulnerability quadrant, and you kind of have more of a mix in the lower condition, higher vulnerability of Long Island Sound sites and Jamaica Bay sites. And we can also go into each site and look at their metrics and kind of see what's driving their total score. So this is an example site in Staten Island showing the total score on the bottom with the chart on top. And as you can see, it does have a higher condition, and that score is largely driven by higher scores across its metrics. And then also for vulnerability, it has a relatively low vulnerability, which, again, as you can see, is driven by the low vulnerability scores across its metrics. Looking at a site in Queens, which is very close to JFK Airport, you can see it has a low condition score, and it, again, has very low condition scores across the board for its metrics. And then the vulnerability is kind of more closer to 0 at the average, which is driven by a mix of both high and low vulnerability scores across each metric. So our next steps are to identify and prioritize restoration opportunities. And we have basically 4 approaches to kind of address 2 goals. We want to optimize the number of potential inland migration acres in the future, and the strategies we'll take to do that are looking at acquisition of adjacent marsh parcels where we have potential migration outside of the marsh complex onto properties that aren't owned by the Parks Department or the city. So identifying those parcels to optimize the marsh's potential for inland migration. And then the same thing, looking at barriers to migration. This is more looking for areas where it will be flooded, but the marsh will not be able to migrate because it's paved, because it's development. So it's mostly roads and things like parking lots. Then we also want to try and optimize long-term viability of the existing marshes and their existing footprints. And the approaches for that would be increasing elevation at the marsh surface to add elevation capital, and then also restoring or building back to that waterward loss from back to 1974. And we've begun doing this. Looking at these, this is a map showing a site in Staten Island, and here the map has the existing marsh complex as well as the potential migration in red, orange, and yellow. And it also identifies the parcels and their ownership. So the areas outlined in blue are city, state, or federal owned, and the areas in green are parks owned, and the areas in white are privately owned. And this is an example area of where the Parks Department would be interested in acquiring this private parcel because, as you can see, it has existing marsh complex as well as potential migration. And so that strategy of acquiring this would help ensure that this marsh has habitat that will not be developed in the future if it's acquired by the Parks Department. And looking just across the city, just seeing the different parcel ownership of where potential marsh migration is projected to be occurring. In future, you can see it is mostly going to be, or slated to be, on Parks property already, with some at 20% private as well as state and city or federal property. Then looking at barriers to migration, this also shows the current complex as well as the potential migration in green, and then the areas identified in red are where it will be flooded, but the marsh cannot go because it will not be able to migrate because it is paved. And here the instances are a neighborhood up here with lots of buildings, or this road, which is Brookville Boulevard, that kind of bisects the marsh. And this strategy will allow us to identify areas of risk for the cities, kind of showing them, you know, this is an asset that will potentially be flooded in future, and then working with planning on seeing how they can best protect their assets, as well as also doing so in a way that will still protect the marsh and ensure that it, you know, it will persist. Again, looking across the city, seeing the different types of flooded barriers. It is mostly roads as well as parking lot, and it's a little skewed because of the site in the Bronx, where it is immediately adjacent to a very large parking lot at a beach. Yeah, so that's what it looks like across the city. And these other barriers are mostly buildings or paved walkways. We also want to look at elevation enhancement, and we're doing this by looking at metrics that show an elevation deficit, so things like percent bare ground or percent low marsh, and the inverse of the total vegetation cover metrics. Again, these are from our field assessments, and ranking those sites in a similar manner as we did for the conditions and vulnerability index, giving them Z-scores and things like that, to identify these areas where we can optimize the staying power of these marshes in future. And another strategy is looking at sites where we can potentially build out. Back to the 74 line, this map here on the bottom in orange shows the loss of waterward marsh since 1974. So the idea being with these would be building back out to this line, and we're ranking these sites based on that amount of loss, but kind of using different metrics such as the width of the loss, and then the loss relative to the total size of the marsh, and then also looking at the potential future loss from the sea level rise model that we used. So this is all still ongoing, and we continue to work with the Nature Conservancy and the Natural Areas Conservancy, and we're finalizing our priority list, and then we're starting to think about our strategy on how we're going to communicate this information and to who, and that's it. Thank you so much.
Great. Thank you, Chris. Any questions for Chris? Just send them to me in the chat box. All right. Well, we'll move on to our next presentation from MassDEP. Please welcome Nancy Lynn and Alice Smith. Nancy Lynn is the Wetlands Circuit Rider Coordinator and had created the Circuit Rider program in 1995. Since 1988, Nancy has overseen the outreach and training for MassDEP's Wetlands and Waterways program, as well as writing and managing grants that forward wetlands and waterways programmatic goals. As a certified professional wetland scientist, Nancy has developed, produced, and implemented many of the program's technical, regulatory, and general outreach and training efforts. And Nancy has listed her contact info here for you. Alice Smith also works for MassDEP as an environmental analyst. She holds a master's degree in environmental and water resource management from Yale School of Forestry and Environmental Studies and a BS in electrical engineering from the University of Rhode Island. And you can also see Alice's contact info here. All right, so I pass control to you guys. Just do a big sweep of the screen, and you should be all set.
All right. Can we do this? Trying to forward this. Uh-oh. All right. Okay, click that. Just a little pause as we get control of the screen here.
And go ahead and give the mouse a big swing so the blue bar at the bottom goes away, and then you should be able to advance your slides.
Okay. Okay. There we go. All right. So Chris covered the results of scientific investigations for coastal wetlands in New York City, and MassDEP's project covers an application using GIS for inland wetlands. We were awarded 2 wetland program development grants from EPA to explore ways to better protect vulnerable wetlands from stormwater pollution and to help 6 pilot communities identify cost-effective strategies to meet the federal and state stormwater management requirements. Protecting vulnerable wetlands for MassDEP means controlling and remediating stormwater pollution. We were looking for ways to help communities meet their MS4 and TMDL requirements. We believe that combining good technical information with a landscape view that GIS maps offer would help towns visually understand the problem and spot potential solutions. EPA funding for this project enabled us to develop the GIS maps as planning tools for these 6 communities. The Center for Watershed Protection defines vulnerable wetlands as the very smallest streams and wetlands that don't have a permanent surface water connection to large water bodies but are still vital parts of the ecosystem. These wetlands are sensitive to slight changes in hydrology, water quality, and particularly to stormwater pollutants. Vulnerable wetlands are defined for our project to include headwater streams, certified and potential vernal pools. Trying to move transition. Okay. There we go. The transitioning's a little slow here. And critical areas as defined by the Massachusetts Wetlands Regulations. They include outstanding resource waters, recharge areas for public water supplies, bathing beaches, cold water fisheries, and shellfish growing areas. The loss of vulnerable wetlands can negatively impact groundwater and public drinking water recharge, as we all know, and it can reduce storm flow in dry weather, degrade aquatic habitats, and eliminate pollution prevention contributions that wetlands provide. On this slide, the areas in red indicate that over 90% of our Massachusetts population rely, at least in part, on headwater streams for their public drinking water supply. Yet only half of these streams are in source protection areas or are safeguarded by the Wetlands Protection Act or the Federal Clean Water Act.
EPA defines headwaters as the uppermost streams in the river network, furthest from the river's endpoint or confluence with another stream. They're the smallest part of the network, typically first and second order streams. For this project, headwaters are upgradient of the first order streams depicted on the USGS topographic maps. They may include ephemeral and intermittent streams that are unmapped or upgradient of all bogs, swamps, wet meadows, and marshes, or otherwise failed to meet the Massachusetts wetland regulatory definition of a stream. To develop the headwater stream data layer, we begin with the 1 to 25,000 scale USGS topo map as shown in this slide. This is a closer view of the insert from the previous slide. The red squares mark the furthest reach of USGS streams that are visible on the maps. The heavy black lines are the USGS subwatershed divides that delineate the drainage areas. Here, the topo map is muted without obscuring the contours. The DEP 1 to 25,000 scale hydrography is used to highlight the stream network and emphasize the branching structure for classification. The DEP wetland data layer, shown here in darker green, was developed as part of an ongoing photo interpretation project of aerial images to locate wetland systems throughout the state. The wetland data describes more fully the furthest extent of streams and hydrologic connections that exist beyond what is shown on the USGS topos. The headwater streams we use to develop our GIS planning tools are the 0, 1st, and 2nd order streams up gradient of USGS center lines. Highlighted here in pink, they reveal new or extended streams and show hydrologic connections between wetlands that were previously considered isolated. Overlapping stream reaches are then subtracted, and the resulting image is manually edited to remove conveyances that are clearly not streams, such as the highway drainage shown in the orange circle in the upper right corner of the slide. We created a headwater stream graphic layer with the remaining information. It shows the new stream reaches and the hydrologic connections that exist beyond the furthest extent of streams shown on the topo. As you can see, there are a number of them, and we can use them to overlay any map. Massachusetts Natural Heritage and Endangered Species Program, also known as Natural Heritage, has certified over 5,000 vernal pools and identified 30,000 potential vernal pools across the state. Though the potential vernal pools have not been extensively field validated, their locations are critical information for community stormwater mitigation and preservation planning. The certified vernal pools in blue and potential vernal pools in pink, mapped by Natural Heritage, are a type of vulnerable wetlands that we used for this project. The importance of protecting undisturbed and upland habitat adjacent to and between vernal pools is widely recognized in the scientific literature. Projects altering wetland resources can disrupt existing amphibian migration routes between vernal pools or between vernal pools and upland nesting areas. Although Massachusetts wetland regulations provide some protection for vernal pools and their 100-foot buffer, recent studies have shown that areas beyond 100 feet are biologically important for breeding amphibians. Also, preserving habitat connectivity between pools is vital to support viable populations. With this in mind, we created a vernal pool cluster layer for our maps. To be considered a cluster requires the presence of 2 or more vernal pools mapped by Natural Heritage. It requires good connectivity between pools with few obstacles to amphibian migration, such as roadways and buildings. It also requires that pools be within 400 meters of each other in the landscape to protect migratory and dispersal distances for juvenile and adult breeding amphibians. Once a cluster is identified, a GIS graphic can be created to locate the cluster in the landscape as shown in this image. Vernal pool clusters throughout the municipality can be identified and documented in a single ArcMap graphic layer. Lastly, vulnerable wetlands include critical areas as defined by the Massachusetts wetland regulations. The light blue area shown here is a watershed to a public water supply. It is an example of a critical area that merits special protection for pollutant reduction plans and added consideration when deciding where restoration efforts would be most beneficial.
MassDEP developed these GIS maps using a healthy watershed planning approach to demonstrate how effective protection of vulnerable wetlands contributes directly to bringing a town into compliance with stormwater pollutant reduction requirements and sustains water quality over time. The town index map on the left shows the Neponset River subwatersheds in white outline for the town of Sharon, Massachusetts. As a small geographic area and integral component of a watershed, the subwatershed is an ideal management unit for locating vulnerable wetlands and investigating stormwater issues in greater detail. A subwatershed is of interest when it is identified as a water quality hotspot, as defined by its impaired waters category. The subwatershed of interest map on the right contains the same information as the index map, but narrows the focus from the town-wide perspective to a selected subwatershed, highlighted in yellow, with a limited land area, typically 2 to 15 square miles, and confined drainage. To design the town index map, we started with a USGS topo map with three-dimensional relief as a base layer. We clipped the Neponset River watershed from the major watersheds layer, assigned a distinguishing color and outline, and used it to overlay the USGS topo relief. The MassDEP hydrography is added to illustrate water features in the community. The town watershed boundaries layer is used to outline the corporate limits of the town. The statewide drainage subbasins layer is clipped to obtain Neponset River subwatersheds only. Each subwatershed that is completely or partially located in the town are assigned a name according to the main water feature within that drainage area. So if you have two or more subwatersheds that have the same primary water feature, an additional identifier is added to that name that reflects the next most prominent water feature. For example, Pequot Brook is used in two subwatershed names. One is named Pequot Brook Subwatershed, and the other is named Pequot Brook Beaver Meadow Brook Subwatershed, reflecting the next largest water feature. The Massachusetts 2012 Integrated List of Waters map identifies the river, lake, and estuary segments that have been assessed and assigned to one of 5 water quality categories. Our project is focused on the segments that were assessed and found to be impaired. These include categories 4A in yellow, 4C in orange, and 5 in red. And go to the next. Yeah. It's a little slow.
It's just taking its time.
I see. It's taking a little time.
Let me try it one more time. Okay.
Adding the impaired waters data layer is our map design. To our map design makes it easy to identify waters for which a TMDL has been completed or is required. Now, the next slide will show that we have the stormwater outfalls added that are shown in yellow dots, as you can see here. They're added to illustrate the proximity of the impaired waters to the non-point source stormwater discharges that may contribute to the impairment. We got these stormwater outfall layers from the community's engineering or highway departments. Lastly, a title, legend, and scale are added to the town index map to identify the symbols used and improve readability.
The data-driven pages function in ArcMap in the blue square allowed us to automatically create a separate page for each named subwatershed in the town index map. To illustrate, this is an example of the Massapog Lake subwatershed area of interest map. The Beaver Brook subwatershed, the Beaver Brook Massapog Brook subwatershed, and the Devil's Brook Massapog Brook subwatershed. A locus map, shown in the black circle, highlights the physical location of the stream basin in the town. For each subwatershed of interest, 2 sets of 3 GIS maps were developed to provide further detail for planning purposes. The first set is subwatershed of interest map type 1. The base map for type 1 was designed using the 2011 orthophotos with overlays of the Massachusetts Index of Ecological Integrity, known as IEI, and the stormwater outfalls. The second set is subwatershed of interest map type 2. The base map for type 2 is the same as 1, except that the Index of Ecological Integrity overlay is replaced with hydrologic soil groups A and B. The subwatershed of interest is used as a fixed extent to develop all the detail maps. We build the base map beginning with the digital ortho photos shown here. The aerial imagery provides a landscape view of the subwatershed that makes it easy to locate vulnerable wetlands as well as potential sources for pollutants. The Index of Ecological Integrity is defined as the ability of an area to support biodiversity and the ecosystem processes necessary to sustain biodiversity over the long term. The IEI overlay used for map type 1 is represented as a range of colors. Areas with a high ecological integrity are shown in blue, and areas with low ecological integrity are tinted brown. The IEI is derived from the UMass CAPS landscape model used as a basis for MassDEP's monitoring and assessment strategy. The DEP hydrography layer is added on top of the IEI to highlight the location of rivers, streams, and water bodies in the landscape. The town-mapped location of stormwater outfalls, shown here in yellow dots, provides insight as to how stormwater discharges might be impacting waters of the Commonwealth. The wetlands layer in deeper green shows the proximity of protected resources to stormwater discharges. 3 type 1 maps were developed. Map 1A displays the vernal pools, vernal pool clusters, and headwater streams graphic layers that we designed previously. Map 1B illustrates critical areas defined in the Wetlands Protection Act regulation. And Map 1C includes industrial, commercial, residential, and other land uses known to have higher potential for pollutant loading. A similar design process is followed for type 2 maps, beginning with the digital ortho photos as used to create the base for type 1. In this case, the IEI overlay is replaced with hydrologic soil groups layers. Specifically, the type A and B soils are shown because they provide the best soils for treatment and infiltration of stormwater. Then the same overlays are incorporated as with the IEI base map set.
We've discussed how to design the GIS maps for stormwater planning, and as part of our technical outreach, we visited each of the 6 communities and showed them how to use the maps. The type 1 maps can be used to identify intact wetland systems, where planning efforts should focus on protection and preservation. When using these maps to protect resources, we advise the towns to look for lands with high IEI value that contain or are near any vulnerable wetlands, or are far removed from stormwater outfalls or from land use types with high pollutant loading rates, and contain wetlands with intact, undisturbed vegetated buffer zones. These maps also help us identify degraded wetland areas where planning efforts could focus on wetland restoration and mitigation of stormwater impacts. When using these maps for this purpose, to restore impaired waters, towns were advised to look at land areas with low IEI values for vulnerable wetlands that were in close proximity to stormwater outfalls, to look for wetlands that were limited or had no surrounding vegetated buffer zone, or wetlands that were in close to land use types that were known to have high pollutant loading rates in cases where TMDL requirements apply. The type 2 maps can be used to identify land locations to cite the structural and low-impact development, or LID, best management practices that most effectively treat stormwater. When using these maps, we advise towns to look for areas with hydrologic soil types, A or B, as defined by the NRCS, in which to set back stormwater outfalls or locate treatment BMPs. These soils generally are well drained and have a greater potential to provide recharge and infiltration. We also tell towns to look at our stormwater handbook for a number of effective stormwater treatment options. And lastly, we recommended that towns follow the 10 stormwater rules of thumb that we developed to accompany these maps for planning purposes. In all of our outreach, we encourage communities. We lost the slide.
Okay, let's go back. See if we can go back.
Hello, Kim. We're having problem looking at the slides or getting to visualize the slides. We're back. Okay.
Here we are.
All right.
We're back.
We're back.
Minor technical difficulties.
All right.
So we're at...
Okay, let me just say if we can get back into control.
53.
Okay. So in all of our outreach, we encourage communities to incorporate low-impact development techniques in their stormwater planning by disconnecting from the end-of-pipe stormwater management systems, distributing and treating stormwater at the source, and infiltrating stormwater on site.
We created 10 stormwater rules of thumb for managing stormwater for Massachusetts communities, but they can be applied anywhere. The first rule of thumb is to preserve all healthy, unfragmented wetlands and restore degraded wetlands. Preserve open space in areas of high ecological integrity. Third, adopt local policies, incentives, and regulations to direct new development to existing infrastructure and improve inadequate drainage systems in roadways and in water and sewer lines. Rule of thumb number 4 is to protect and restore vegetated buffers around wetlands, at least 100 feet if possible. Number 5, use low-impact development techniques that reduce, infiltrate, and evaporate stormwater. 6, keep water local by maintaining the existing hydrology when building new drainage systems, recharge and infiltrate the stormwater on site.
Number 7 is use low-impact development techniques that reduce, infiltrate, and evaporate stormwater and keep water local by maintaining the existing hydrology. Don't use stormwater for stormwater treatment or new discharges. And 8, create a setback or treat existing discharges before reaching the wetlands, especially near public water supplies. A buffer of 100 feet or more are better at removing pollutants, but 50 feet setback should be a minimum design practice. Avoid storm. Okay, and lastly, treat stormwater for pollutants of concern as identified by TMDL with the prescribed treatment practices. Consider soil conditions when selecting a best management practice, and remember that not all discharges are created equal. The hydrologic soil groups A and B work best for infiltration, but in areas where soils have poor drainage, they should be looking for alternative treatment BMPs. In closing, thanks for attending our presentation, and if you have any additional if you need any additional information, contact us. Reference citations and links for the Vulnerable Wetlands presentation can be found at the MassDEP website under Education and Outreach.
Also, for your information, we've completed a 6-part YouTube video that covers in detail how to make these maps for anyone interested in designing their own. Thanks for coming.
Thank you all. We've got an email to you already. All right.
Thank you.
So let's go ahead and unmute the lines and address some of our questions.
Your line has been unmuted.
Hello?
Oh, hello.
All right,
I was talking
everyone.
to nobody.
Hi.
Hello?
Hello?
Sounds like Trish. Hi,
yes,
Trish.
yes. Hi, how are you? I was talking to nobody for a while there.
We had some technical difficulties with this slideshow, so, but we're glad, since EPA did help fund this project, that you're there online.
Yes, I know, and it was quite a few years ago at this point.
Yes.
But I remember when we first funded it, I thought, wow, this is really solid idea, and I'm so pleased to see how far it's come and how you've been able to really pull it all together. And I'm curious, you know, how the towns, you said you worked with 6 towns, of course, I'm curious which ones, but how did they react to the information, and or how have they used the maps as far as you know?
Well, we presented the maps to what we did for each town, and there were 3 towns, pilot towns in the Charles River watershed and 3 pilot towns in the Neponset River watershed. And the meetings that we set up incorporated all of the boards that were involved in planning board, conservation, and any other boards who were interested in joining us. And they were very receptive. We provided a demonstration of the maps and a discussion on vulnerable wetlands in the community, and they were very receptive. We haven't spoken to them recently, though we did notice a lot of enthusiasm at having the maps to use, but we could follow up again to see how they're actually, if they're still using them, but we haven't done that recently.
But, you know, I do want to say that we also presented it statewide at the Massachusetts Association of Conservation Commissions Conference, and there were a lot of GIS folks that were there for other communities, and they wanted to learn how to emulate and create these maps themselves for their communities. So that's why we're producing, we're actually in the process of finishing 6 YouTube videos to present to put online so that any community anywhere actually can use the process that we developed for creating their own vulnerable wetlands maps, and to use all those different features that we discussed in this presentation.
Oh, that's terrific.
Did that answer your question, Trish?
Yes, it did. And I think, you know, it's always challenging to kind of circle back around again, but I think we have to do that in a way. It takes time for people to kind of absorb what's going on, and maybe with the new MS4 permit coming out, there'll be an additional interest in, okay, well, how can we do this stormwater stuff right? And so I'm really glad you have this foundation, and I just would hate to see it stop. You know, I don't know if you have funding to continue to keep getting it out there and talking about it, or how that works, but somehow we should figure out how to fit it into, you know, where we're going, how to go forward with all the stormwater stuff in Mass.
Yeah, because, you know, it's a good, we sat down with, you know, the whole wetlands program here and said, you know, what do people need to do to evaluate the stormwater situation in the towns and help them come into, what can we provide to help them come into compliance with MS4s, TMDLs? And so, you know, I think the strategy is a really good one, and I think it offers the towns the ability to focus their funding, any funding that they have available and their effort into a manageable unit, the subwatershed as a manageable unit for both in terms of land area and in terms of drainage. It's confined drainage. So it allows them to focus into those subwatersheds where they can get the best return for the funding that they have available.
Mm-hmm.
Yes, and I think, a follow-up would probably make sense, and we certainly think that putting the YouTube videos out there, which should be out in probably the beginning of next year, would help with that effort, and also it would probably bring it out to a lot of other people where they can, we can respond to that.
Mm-hmm.
I see a hand raised from Sandy Crystal. Did you have a question?
Yes, thanks, Kim. I was just curious, this is interesting, and I wanted to find out if the subwatersheds were actually like a Huck 12 layer. Do you know the USGS, the hydrologic unit code, they refer to them as Hucks, like a Huck 12. So I didn't know, which is a smaller watershed than a Huck 6. I don't know if you're familiar with that.
Yes, they are. They are. And in fact, in identifying this particular, because this is funded by Wetlands Program Development Grant, we had to identify the Huck layers for this project. Actually, it's 2 projects, 3 towns for one project and 3 towns for another project. 3 towns for the Charles River, 3 towns for Neponset. And if you're interested in what the Huck numbers are, we can share that with you, but I don't have it in front of me.
Yeah, just, we have the Huck layers too, and I was wondering when you talked about the subwatershed if it was down to the Huck 12 layer level or whether you had done something further. So, all right, great. Thank you.
We also have a bibliography online. It's under the under the Wetlands Program Outreach and Education area, and that has a list of not only the citations for the text, but also a list of all of the data sources that are involved with these maps. So most of them are available on MassGIS. Some are internal, but they're all labeled and with a lot of detail, so anyone looking to locate that information, it would be easily accessible.
So I think, to answer your question, Crystal, I believe it was this Huck 12 layer that we were looking at Huck 12 level, because we were getting closer and closer to getting, we were trying to really focus on a very discrete unit, a drainage unit, in order to deal with the planning and to explain the planning pieces to each of the communities. So it's not even necessarily within, it was even more discrete, even within a community, drainage basin, the confined drainage basin that we were working with. Does that answer?
That's helpful. Yes, good. Thank you very much.
You're welcome.
And that's Sandy Crystal.
Yeah.
Oh.
Not Crystal. Sandy.
Okay, Sandy.
That happens all the time.
Does it? I bet. Yeah.
I had a question for Chris. Can you talk a little bit more about how extensively your region's using salt marsh deposition to enhance accretion?
Yeah, it's been applied in huge projects in Jamaica Bay, on National Parks property at those island sites in Jamaica Bay. Yeah, those have been going on for many years now. But we haven't done any specifically in New York City on city property in terms of adding elevation to sites yet, as far as I know. But that's something that we're looking at in terms of ranking and seeing if it would potentially be, meeting with stakeholders and getting their feedback and on the planning level as well as potentially on the community level as well, and seeing how, they interpret that and as a strategy.
Thank you. All right, any other comments or questions on the line? Okay, well, seeing none, I will announce our next webinar, which will be January 14th, continuing with the second Thursdays of the month. Same time, 1:30. That will feature some assessment methods presented by Andy Cutco and Justin Slane of the Maine Natural Areas Program. And if you are interested in presenting, please look for another call for presenters. For spring and early January, it will be a similar survey-style abstract submittal portal. All right. Well, thank you, everyone, for joining us today, and I hope to see you again next month.
Thanks, everybody.
Thank you.
Thank you.